Hello and welcome back to IT Security Labs. I'm very excited and thank you very much for joining me tonight. This is our weekly live stream where we actually do some hands-on information security labs learning. Unlike other things that you have seen out there, on this channel every Sunday at 9 p.m. Central Standard Time, we actually try to get our hands dirty and get on the keyboard and start learning information security skills. I think that is the best way to learn, and no one else can ever take that away from you, because not only do you get to practice, but you do these things so you can go out there and tell people what you have done and also get better as an information security person. So thank you very much for joining me tonight, and I really appreciate everybody who joins. We've been doing this for a long time, and I hope you keep joining me every Sunday, because I know for a fact you will learn something new today. So thank you again for joining. I really appreciate everybody who joins. Today's machine is called Checks. I made this machine myself, and it's a Windows machine. It's supposed to be a 10-point OSCP, like offensive security, ethical hacking type of machine. But the biggest part is you're going to learn how an attacker is going to get access to a Windows machine that is running a vulnerable application. We're going to scan the machine. We're going to exploit the machine. And as always, we have Security Onion, our intrusion detection system, which is actually listening to this traffic, so we get to see what traffic looks like. I think this is by far the best way that you can learn information security skills. So instead of going out there to employers and people and saying, hey, I'm a good learner, take a chance on me, you can do this, what I'm doing tonight, and you will actually be able to see that you can learn these things. And when you show up to an employer's environment, or even at your current job, they will be amazed at what you know, because you do these things hands-on. So without wasting time, I actually have my lab already set up. So I'm going to show you, some people have asked me to show them what the lab looks like. So before I do the attack today, I'm going to show you what it looks like. It's a very simple lab. You don't need a lot of money to set this one up. It's as simple as it goes. So here we have VirtualBox. It's actually cut, so let me minimize that. All right, anyway, I'll just show you the part that it's cut is fine. It's VirtualBox in here, and VirtualBox is actually running my machine. It's called Checks. So it's right here. As you can see, I have a few snapshots. I have a Kali Linux machine on the same network, but also it's just a machine running in VirtualBox, nothing special. And in addition to that, you can run your Kali Linux in the same VirtualBox environment, give it the same network as the machine, and off you go. So my machine has 24 gigs of RAM, but I don't think yours need that much. You can just attack this machine with the bare minimum that you can get. My Kali Linux right now is running Kali 2019.3. I still need to upgrade, and as you can see, I'm in the machine. So my VirtualBox machine is actually on 192.168.38.34. So we start with the ping, make sure that it's responding. And after it's responding, we just do a simple scan. This is a classic 10-point machine on the OSCP. And what that means is when you go to the OSCP exam, which is the offensive security exam, there's one machine. Usually it's 20 or 25 points. There's one very simple machine that you should spend no more than 20 minutes. You literally scan the machine, you find some running service, you Google the service, you find an exploit, you point, you shoot, it works. That's how simple the 10-point machine is, and today's machine is exactly that. So first, I'll start with an nmap, -sv, -sc, 192.168.38.34. This will do the top 1,000 ports. You want to make sure that you do this. And Nmap is going to scan this machine here for any open ports. And ports are just like doors. A system has ports that are open or closed. And if the ports are open, we try to figure out what's running on those ports. And that's what this service version is going to be. It's going to find the version and also the service. If it's Apache, if it's a database, it will find it. Then this SC is going to use default scripts from within Nmap, the bare minimum to see if we can scan and find things about the system. So that's what we will be doing with this here. And let's just hit enter. And as always, like I say, we are actually detecting this. An intrusion detection system is really going to catch you if you're doing this kind of business in someone's environment. An intrusion detection system does exactly what it says. It detects intrusion. A scan like this is bound to trigger an intrusion detection system. So let's look at this intrusion detection system here and find out what it's going to do. So if we go to alerts, it's going crazy right now. It's literally going crazy. Look at all this noise here. This is all because we just scanned a system. And that's how you know that someone is scanning your network, because in this case, Security Onion is like, wait a second, I'm seeing a lot of traffic from Nmap scripting engine. What's going on here? And you can go in there and try to figure out, okay, what are you talking about, Nmap? Surikata in this case says, hey, I did see Nmap scripting engine in the user agent. We think we're getting scanned. So if your goal is to hide, do not use Nmap in a production environment where you're trying to hide, because the Nmap has a user agent that it sets, it will trigger it. Same as other tools like Hydra, Nikto, and those popular tools that you use out there. They do have a user agent that they will trigger. So most of this noise that you're seeing in my alerts here is because of this. And this is what most of the people spend their time on. A lot of people don't become penetration testers. A lot of people do this type of stuff where they see this noise. And if you have never ran Nmap in your life, you'll be assuming what's happening. If you ran Nmap like what we did, you know this is just as simple as VSC scan, and it generates not only the first one, but everything else here. Rod says, can you change user agent in Nmap? I think you can spoof. I know within Nmap, you can spoof other people's IP addresses. I'm not sure if you can change the user agent. That would be a good one. That would really be a good one to do. Now I have something to do after this class. After this session is done. But yeah, so we got caught, and here is what we see. One thing that we would like to see every time is, you have seen me attack 7 or 8 machines on Windows consistently over the past 8 weeks. You know, these things are always going to be open by default on any Windows system. By default, 445, 135, 139 are going to be open. What else is going to be open by default? These RPC. If an administrator does not explicitly disable these, they are going to be open by default. This is going to really help you if as an attacker, because you know, chances are there isn't much going on here because they are open by default. So you will start enumerating everything else, and these ones will be the last things you look at because by default they're open. And same as this port here, 4700. I remember my first time attacking Windows, I thought this was a real website. I spent so much time running Nikto, GoBuster, JBuster on this 4700. It's a useless port. It comes open by default in Windows, and knowing that is going to really save you a lot of time because you don't need to be running GoBuster on this silly port here. Unless if somebody is really playing games, this is a default port. Enumerate it last. Look at everything else. So by doing that, we eliminated these. We still have 8009 here. By the way, this one also is another default port that comes by default in Windows. This is you knowing how Windows behaves. And these are some of those little nuances that really help. Remote desktop is not usually open, but of course, people are lazy. They would like to use RDP, like myself. I'm using RDP. So once you get credentials, sign in using this one. All right. So with all that said, 445 enum for Linux will do the trick there. So we can run our enum for Linux. We're not going to do that today. I've done that. I think I did that last week. Let's go straight to where the business is. Port 8080. It says it's running Apache Tomcat 9.0.13. This is what a 10-point machine in the OSCP is going to look like. Very straightforward, no games, no gimmicks. There probably is a rabbit hole here and there, but really, it's going to literally give you something very straightforward like this. So first of all, we know that it's 8080. So why don't we just go to that port right now and find out? It's got 34. And sure enough, we're faced with a default Apache website. If you have not attacked this in your life, I think you should practice more. Anyone who is going for an OSCP or is just doing ethical hacking, you have faced Tomcat at some point in your life, because it's a very, very popular application that people like to put vulnerabilities on. However, the one that I have here is a very common one, but at the same time, you still need to think, right? You're not just going to point and shoot. First of all, we get the version right here. Sometimes you see the version all the way at the bottom, but right now we see the version is right here. So what better way than just take that and type the word exploit in Google and see what happens. So we do see that for the exact version, we have one from CVE details. Then we also have another one from Tenable. And we have this JSP X upload. So we do have a few. This is not fun to read, so I'll move on. And here's another one from Tenable. This is talking about cross-site scripting. In most cases, if you see cross-site scripting, at least for the OSCP, I'm not sure if cross-site scripting is the most fun and likely vector. It's usually remote code execution or file upload or something that's actually more straightforward than this. So because of this, I would move on. All right, this one talks about JSP upload, remote code execution 2. And unfortunately, if you look here, it doesn't tell you whether this was tested in Windows or if it was tested in Linux. It just gives you a Python script. And that's really not ideal. If you find something like this, it's really not fun to deal with. Then you actually have to read through this and see, okay, was this targeted towards Windows or was this towards Linux? And one way to see that is by looking at what kind of commands is it running. If it's running like cmd.exe or PowerShell, you know it's Windows. If it's running anything like that, you know that it's Linux. So this one, it looks like we have actually, it's a JSP one. It might work for Windows and Linux as well. And it does upload a web shell, which is interesting. So we can try to find this one within SearchExploit. So the first thing is, before you download this from the internet, just go to SearchExploit and see if you can see it. That way you save yourself some time and errors of downloading this from the internet. So do a SearchExploit. I'm pretty sure a lot of things are going to come up here. So we do still see that we have version 9.01. It's 9.013 that we found. That's very important to keep track of. And we also have this one. And I'm pretty sure if we get this, that's the one we saw on the internet, because there's two. So let's get this one. So SearchExploit -m and pasting the name of the exploit, it will copy it here. And it copied it as this one. Let's just say no here. So let's run that exploit. If you're unsure on how to run it, you just type Python and see if it runs. Right now, first time it doesn't run. So maybe it's Python 3. And a well-written exploit will tell you, hey, by the way, this is how you run me. You run the name, you then specify the URL. You're like, okay, so let's see if this is going to work. -u http 192.168.38.34. Do I need to put 8080 or not? It doesn't say. So first time it fails. I know it doesn't like that. So I need to put 8080. And guess what? Not vulnerable. So this is typical and classic, where you go to an exam like the OSCP, or you're doing hack the box or try hack me, and you do some Googling, the first exploit, boom, it bombs on you. That's perfectly fine. One thing that you're going to see is from the OSCP and even try hack me or hack the box, those platforms, one thing that they will teach you is patience and persistence. If you're someone who is not patient, who gets frustrated by little things easily, especially technologies and errors in the command line, practicing hack the box, try hack me, proving grounds is going to really, really teach you the one thing called patience. You have seen me on this channel where I'll try to attack a machine, even the ones that I've created, and they don't work. One thing, stay strong up here. If you're weak up here, you will be frustrated. You will not enjoy the process of exploiting things. And that's a given fact. So it didn't work. We went through the process of just downloading this thing. That's okay. Someone says, let's go ahead and check Apache for default credentials. Yes, we actually didn't do any of that. Let's go here and see. I didn't even check to see if I have any other things here. We could have seen if we have a login page. We have a host manager. Most of these are going to fail because I didn't set this one up to do anything. So, server status. This is a default installation of Tomcat. So, a situation like this will be an administrator set it up. They were trying to practice. Then, because they're careless, they don't have good security hygiene, they left this thing running and they moved on with their life. And this has been running for years now. You can even try to do the setup here. Yes. All right. So, since we already know there's nothing else this thing is going to do for us, I mean, you can try on the documentation. It will show you the docs. Yeah, but make sure to click around here to look for pages. Also, one thing that I didn't do is, the least you can do, run Nicto on this thing. Run Nicto like this, and Nicto will tell you if there's any other vulnerabilities. In fact, let's run Nicto. It's going to generate a lot of noise for us, but that's fine. We already know the version here. Sometimes you don't. And this little tool called Nicto here can give you the answer very quickly from here if something is really terrible on the server. Like this one. BT says to go to 8009. Let's see. Yeah, that one was not configured. I didn't configure this thing to actually work on anything else. All right, so Nicto is going to tell us the same thing. The one dead giveaway is we have a version right in front of our face. So it makes sense that we'll go and looking for that version information and make sure that it's actually running. So let's make sure to go and run Nicto. And once Nicto works, we should be fine. Let me see. Nice. All right, let's see. BT is insisting that we got 8009. yeah, this. All right, so since we have a version, we still haven't finished exhausting this version here. So let's finish that first. Then we check the other ports. But this is the output from Nikto for us right now. It does find really helpful things, especially on Hack the Box and Try Hack Me. I find myself having a better time working. And we also have the manager here, if you wanted to see. In addition to a Go Buster, Nikto can and will actually give you some interesting information. Let's see. All right, so just because the exploit that we ran from exploit.db did not work does not mean that this version here, we just ignore it, right? Another thing that I would like us to go and do is modify this search a little bit and put the word git. The reason why you would want to do that is because not all exploits that you're going to be using come from exploit.db. Even in the exam for the OSCP, I remember very well there were a couple of machines that I did not use exploit.db for the exploits. But GitHub is a very good place. Other people's blog posts are very good places to actually go and do that. So here is an exploit that someone, I don't have to include that. Here's another one from GitHub. And here's a proof of concept. I like people's blog posts a lot because then it actually shows you how things can be done. And this time, actually, I don't have a blog, but I do have a GitHub page here. Let me see if I can see another one. I found another one as well. Let me show you. This one. So the idea here is, and this is where it goes to people who say, I tried everything and it did not work. Did you look at other exploits other than from exploit.db or searchsploit? Did you go through all the results, at least from the first page of Google here, to read about the exploit? So if you go out and say, I tried everything that I could, I'm always skeptical. And for the exam, and especially for the OSCP, that's always the case. You did not try everything you could because there was a way you just didn't try enough. Maybe you didn't do a simple Google search and open a few of the pages that showed up here. That could have been just all you needed to do. Read the first page of Google after looking up the exploit and see if it's there. In this case, we actually see we have this GitHub here, which I think that's the same exact exploit actually that we had earlier. And this one talks about, actually, this is the same one that I found. It's probably on one of these pages here. And if you find it here, it'll be this one. And this is another proof of concept where we also have remote code execution. And another really cool thing, I don't know if I'll get in trouble with OffSec for this. I actually, during an exam, I found a proof of concept video. I mean, there's nothing better than finding proof of concept videos where someone is showing you how things are done. I don't know about other people, but in the exam, when I was looking up my exploits, I actually did find someone with a proof of concept, and they actually show you how it's done. And this is just a way of saying, guys, when you are looking at exploits, do your best. And here I'll teach you a few things. Search for Tomcat 9 and do this. If you put quotes and do Hack the Box, this will give you the results only from Hack the Box. Right now, it gave you a Hack the Box where Tomcat was used in Tabby and other things. Replace that with VMware. It will show you machines where Tomcat was used from VMware. Replace that with Try Hack Me. it will show you machines where Tomcat was used in Try Hack Me. This, what I just did here, I did the same exact thing when I went for the OSCP, and you'll be surprised. One of those, on one of the machines, once I found a service that was vulnerable, and I did those with those quotes, I did see a full walkthrough from someone from one of those platforms. So you can make your life 10 times easier by searching for, with quotes, Try Hack Me, VulnHub, Proving Grounds, and all those platforms like all those other machines, and you will find a walkthrough with the same exploit that you're working on in an exam, and all you have to do is just look how they did it and smooth sailing. I did that for the OSCP, and I hope you know that, because if you try to reinvent the wheel when it has been done before, you'll be not be doing yourself a favor. So that's another thing that I wanted us to take away from today's. Even though things are easy, make sure to be good at your Google full, because you can make your life 10 times easier or harder if you don't know how to Google things. All right, so here we can read that this Tomcat Apache is vulnerable to CGI servlet, and you can read all this here. And there's things that needs to be enabled on the server for this to work, and affected versions include 9.00M1 to 9.17. So this includes our version for sure, because we can see it's part of this. And we have a video that will show us the exploitation steps. We have instructions on how to set it up if you wanted to do a proof of concept, and make sure that it's actually working. There's in this case, they said ism.bat and dir, which is what I did. So they're saying go to that and go to CGI ism.bat. If it was set up like this, you'll be able to use this one. If ism.bat didn't exist, you'll still be able to use this exploit. This is just a test. So I'm just going to copy the last part here, the CGI, and make sure that my version works like that. All right, so this is what I'm seeing. I ran the command dir here, and I can see the contents of this file. And according to my proof of concept, that's what I should see. After this, you know you got this machine down because you tested everything. So most of the work for this machine was you Googling and making sure that you find the right exploit. Without finding this exploit from this list here, which is one, I think it's one of these. Yeah, it's somewhere in here. In fact, any of these should work. Then after this, all you need to do is just do a git clone of this repository and run the exploit the way they did it. Again, here is where your skills really matter. You need to be able to follow other people's proof of concepts and follow them well. You find someone's blog, you find someone's video, you need to be able to follow it well. By the end, we're going to talk about this mitigation here. But for now, if we look, there's three things that are happening here. One, there is a listener on Netcat NLVNP on 1234. So we need that listener. We need to set up a Python HTTP server or any other server on a different tab. We do it here. Then we run the exploit right here. Okay, so it looks like we're just running the exploit using Python 3, and it's not modified. We didn't modify or do anything like that. So we need to go and modify this exploit. If you do not know how to read Python or any other exploits, you need to spend some time practicing. So the exploit is in here. So I'm assuming you did this. Let's not make any assumptions. Let's just do it. you clone this repository. It's a Git repository. So to clone it, you run git clone. You paste that link, you hit enter, and if you do an ls afterwards, you will get this file folder here. After being in this folder, you will notice that we do have the CVE file that they're talking about. Let's go back to our exploit. It's Python 3 CVE, whatever that is, .py. But of course, we're not going to run this by default. This is not going to do anything for us. We need to make sure that this is pointing to our victim. So let's copy that. I don't like to run with the original, just in case I mess it up. So I make a copy, which is a smart thing to do. Because if you mess with the original, then you have to git clone again. Just make a copy. Okay, I'll name this one exploit. Okay, I already named it exploit.py here. So I'll name this one exp.py. Okay, now let's look into this exploit. If you have never spent some time learning Python, you might struggle. Take a Udemy class for $10. Get yourself familiar with Python. Know what Python modules and how to define variables in Python. The basics for Python. If you don't know Python, you might still be able to make this work because it makes sense anyway. But it really helps if you know what you're looking at. So host is equals to, it says add host to connect. So this person wrote a nice exploit. Our host is 38.34. The port is 8080, so we didn't change the port. If the port has been moved, you need to change this one. Then server IP, this is the server that has netcat file to get reverse shell. So we need to upload netcat to the victim. So this needs to come from our Kali Linux. So let's do it from here. Let's use this one. If you do an ls, this exploit does come with netcat.exe for you. So all you need to do is find out what the IP address is. It's 192.168.38.60. That's our IP address. That's where we'll be hosting netcat. So we change this to that IP address. All right. Server port is going to be 80. That's the server that we will be using to host our good Python 3 server. Then netcat IP, this is the IP that netcat is going to run, which I will show you in the commands here. This is going to be where netcat is going to code to, which is our Kali Linux. So it's the same as the same IP address as where we're hosting netcat. All right, netcat port 1234. I'm lazy, so I'm going to leave it on 1234 because why change it in this case? If you are in an OSCP exam, you want to change this to a port that's already open on the system. And that is a big deal. You will not catch any shell if you don't do that. So if you are in an OSCP, you come and put 8009 or one of these ports here. If you don't do that, I've seen it, it doesn't work. You use one of these ports here. It's one of those firewall restrictions that they will put on you. So 1234 is fine for us. Why don't we then try to see what this is doing? So it's going to run our good friend. You have seen me run this tool before. setutil is what we're going to be using to move the file here. We're going to be moving netcat to the server. Then we're going to run netcat afterwards to get a reverse shell. This is as simple as Python can be. Oh, thanks for catching that. My reverse shell was not going to work My reverse shell was not going to work, and I was going to be scratching my head here, wondering what's happening. Thank you. It's good to know that people are paying attention to that. So 192.168.38.60. All right. So this is a very simple script. It's literally going to the server using the ISM bed and running setutil. But of course, I would like you to know, if this had failed, I would modify this part here and replace it with my own command. This whole part here. If their default one failed, you should know. You can change this and maybe try Python. It doesn't mean that you have to rely on what they have. So far, we are just lucky that it will work. But a good part of knowing how exploits work is, well, where are we really injecting the commands that are working? So far, this IP address is made up, but where is the source? Right here. And what are we doing? We're running setutil to download netcat, and after we download netcat, we're going to run netcat here. So it's going to be netcat minus exe, then our IP address, then the port that we're listening on, then minus e command.exe. You have seen netcat reverse shell. That's exactly how it's going to do it. And if it fails, it will tell us, hey, by the way, we had an error. If you look at this and you see gibberish, just take a simple Udemy Python course. I don't think Python is that bad, and we should be good. All right, so that's the exploit that we have. After we do that, a few things we need to make sure that we do, because this is going to try to download netcat from a port 80. We need to start a server to host netcat. Netcat is here. And remember, if your netcat is from your Kali Linux, make sure that you have the correct binary that is not corrupted. I've been burnt multiple times with corrupted netcat binaries before. So make sure you don't do that. Or if it fails, always check that your binary is the 64-bit version and it's not the 32-bit, and also that it's not corrupted. And the easiest way to tell if it's corrupted is once you move the netcat, it will be very small. It will be like 500 or less bytes. Then you know it's small. It has to be a bigger file than 500 or something like that. Okay, so let's start our listener. On 80. Geez, today I cannot type at all. So it's Python 3 HTTP on 80, because right here, our exploit is looking for port 80. If you're trying to move this in the OSCP and 80 is not open, and your exploit is failing, go back to your port here. Host your netcat on one of these ports. Host your Python 3 even on 8080 if you have to. Pick one of the open ports on the victim. That seems to do the trick. So if your exploit is not working and you're banging your head and you know it should work, it's all about the ports most of the time. And a lot of people will be looking elsewhere other than these ports here. All right. So once we do that, the next part is we need to know, okay, where are we going to get our shell? It's going to come on 1, 2, 3, 4. So let's start a netcat listener here. On 1, 2, 3, 4. All right, so we have a listener. We are hosting here. What's left is for us to just run our exploit. So it's Python 3 exp.py. If you run it, unfortunately, this one doesn't talk. It's mute. It just stops. I like to go here and make sure if you see 200 from a HTTP server, you are in business. Things are working for you. Then, of course, we can come back here and we did get our reverse shell on the machine. So the biggest takeaway here is be very comfortable interacting with public exploits that you see from the internet. If it comes in PowerShell, if it comes in Python, you should be at home. You should just be looking at it. Okay, what do I need to change in here to make it work? And after it works, we're in here. you're going to notice right away that this is not a very friendly shell. If I run dir, I guess it works here. But if I do a who am I, it doesn't like that. It's because this shell is, unstable, and you can rerun netcat here and catch it again to see if you actually be able to get a stable shell, or rerun setutil to get a better shell. But right now it looks like I can move around. And I see the administrator here. All right, so that is the flag here. For fun, because it's me, I put you a base64 encoded flag here, because why not, right? You know it's base64 because of these two equal signs here. If you have never done a lot of CTFs, this might be new to you. If you've done a lot of CTFs, you see some random string ends with two equal signs, you know it's base64. So let's decode our flag since we're already there. Let's echo that flag to base64 minus D. And that's how you decode base64 minus D. And the secret message that I put this time is, you can definitely pass this exam if you're going for the OSCP. But if your goal is to just become a better learner and just know how things work, this is definitely fun things to do. So I highly encourage you to join me in this journey. The best way to learn information security, as you can see here, is let's just attack these machines. Let's do this consistently, and let's show up. Most of the time, it's just showing up and doing it, right? Once we show up and we do it, we learn something. So right now, we did get our flag. We attacked the machine. We got a ratio from an exploit. That's just a 10-point machine. That right there is exactly what a 10-point machine would do. You drop into administrator. There is no privilege escalation, but you still have to work for the initial access. You don't just get in there. You still have to work for it. All right. So first of all, we did an attack. Let's do our best attempt at finding out what's happening here. Right away, you will notice that our baseline was we were getting less than 100 events. This is in Security Onion, but all of a sudden, right here, 66. This is how much noise we were making, because we, of course, as noobs and script kiddies, we're just running scripts. When you run scripts, you generate a lot of noise. And this is how much noise we generated. To a well-crafted environment where they are doing proper detection, they will catch you while you're still running your scripts. They will know that you're onto them, especially if you do something like this, and they'll block you. You'll not be able to go anywhere. But of course, this was us generating a lot of noise. So this is what our tools did. And I think Nikto did this right here. Nmap did this right here. Because I ran two major tools today. I didn't run a lot. So we can go and look at this in the alerts section. Most of the noise is going to be coming from Nikto and Nmap, unfortunately. So it's going to be a lot of noise for the incident responders. But if they are familiar with this traffic, hopefully they'll be able to quickly realize, oh, this person is just running a bunch of tools. Nothing has happened yet. But as you can see here, all this here is coming from all of our tools. This one is saying exploit suspected PHP injection. I bet this is Nikto. Yep. That is Nikto right here. Because Nikto does try to do some more tests that gets it caught, and the user agent always gets you caught. So if you run Nikto and all these I'll do them for practice, but if your goal is to do a customer environment and the customer is intrusion detection systems, I wouldn't be running the tools the way we're doing them here. All right, so we generated a bunch of noise from these tools. There's only a few alerts that are very, very interesting. The rest are just going to be a bunch of garbage. This one is a download of an executable file. Executables are dangerous in a Windows environment. So every time we see that something to do with executables has happened, we would like to go and find out. All right, so it looks like it was downloaded from HTTP. So we are interested. It tried to decode the executable here. This is probably some gibberish from an exe file. But here, it tells us that it got this executable from a simple HTTP server. Do you remember when we ran Python simple HTTP server? So now, you as an incident responder, you're now going to be saying, well, this person is running a Python 3 simple HTTP server. This executable came from a simple HTTP server, which is very suspicious, right? So now you know something is really up here. So let's look at the other ones to see if we can find this exact file that was downloaded. Now I lost my alert. Okay, I'm going to move on. We can actually find that executable if it's somewhere in here, and you can download it using you can use Wireshark to extract it from PCAP. I was interested in this netcat exe URI, which is interesting, but I'm not seeing it anymore. Okay. What about this one? I bet this is Nicto again. Given the numbers here, yeah, it's Nicto. So you after you have seen these tools a couple of times, I've seen these in my lab. I know Nicto does this kind of stuff here. So the interesting alerts are going to be coming from here. Okay, back to our alert. I really want to see. Okay, this is the netcat file when we moved it. If you see here in the message, I guess I could have looked in the message earlier. I don't know why I left. Netcat, when you move executable files in an environment and it's not encrypted, and things like this will happen. You'll get caught, of course. And again, we see that it's coming from Python 3 here. So if you wanted, you can do something like this. You can request a PCAP and find out what's in this file here, which is a very, very simple process. So let's request a PCAP. Under Actions, give me a PCAP file. A lot of people interact with PCAPs all the time at work. So interacting with PCAP here is not surprising. You see the full TCP handshake, so this can tell you a story. Who started this fight? Looks like 192.168.38.34 is the one who did the scene. Then, of course, CNAC happened here, and a file was downloaded. So what I like to do is I just like to download this file, open it in Wireshark. Let's hope the file is in there. Then we can just look at it. My Wireshark is kind of already set up. It's color coded, like HTTP traffic is going to come with this yellow stuff here. But here is the file that we got. You know how we moved this file. So this should not be surprising to see it. But for incident responders, this will be news. This will be gold, right? We found the file that they moved. Usually it's probably not netcat, it's probably like a virus. Okay, so now that we found this file, how do we extract this file so we can actually analyze it? Maybe you have people who are very good at malware analysis or binary analysis. You need to send them this file here. They'll be like, hey, where is this file that you talk about? In this case, our file is just netcat, but it could have been worse, right? So I think if we go to File, Export. Where's my export? I always... There's always an export object. This is an HTTP object, so I can export that. Come on, I was hoping it would be here. Let's try again. All right, so it's not exporting here, but I've been able to export this exact file here if we had it within this PCAP, and then you'll be able to actually see it. Maybe I have the wrong package, so we can try to go and see if we can get another one. But this should work. I don't know why it's not exporting it. Anyway, this is how we export objects if they were in there. And then you can send this to your incident responders. Or you can just use this information here to see who was doing most of this, who initiated the conversation, and see things at a packet level, which is really, really fun, because then they tell a better story when you look at it this way. Another interesting thing that we can do is, let's just go and look for our reverse shell in the discovery here. I'd like to see when we got our reverse shell. You probably have seen this through your investigation. But I think we had port 1, 2, 3, 4. I hope we can find it. Oh, that is not ideal. I used a very silly port. It's noisy. It's a very noisy port. This is why I like to use better ports. Okay. Let's do an AND. Destination. No, I just want the destination IP of 192.168.38.60. I hope I can see enough now. All right. So when we do this, you can see that a reverse shell was triggered, or at least this port here was involved going to that destination IP this many times. Let me see if I can see. This one is interesting. I don't know what you can see, so I want to make sure. Look at this. Even the error messages that we got in there showed up in here. This is us interrogating the network, trying to really figure out what's happening. Why do we do this in a lab environment? This is how we can get better at our skills at knowing what network traffic looks like when it moves through a network. If you are going to be an incident responder out there, you really need to know these things in and out. You need to know, okay, what does network traffic look like when it's moving around? What does a file look like when it's encrypted against when it's not? In this case, nothing was encrypted. And of course, we can see in the data network.data.decoded here. If you looked at a PCAP as well, you will be able to see this information, but it's just nice that we can see it in here. And according to our rule, it thought that this was a Trojan. But of course, it was just a reverse shell that we got, and we can see this. What else can we see? That was netcat and a reverse shell. That was about it. We didn't do anything exciting other than this today. So right now, yes, I agree. This is so much fun. It's actually very, very exciting to just, you don't get a lot of chances to just interact with network data and see what's happening and attack things. This is really, really cool stuff. If anybody has any questions, please let me know in the comments. But this was a simple 10-point machine from the OSCP, and we could just attack things and see what happens. There's obviously a lot of things that we can track down, but those two I think were interesting, just being able to see the files. Now, what's bothering me is, why can't I download that file? I know it's in there. And it was a 200 OK. So If anybody knows why I couldn't download that file from Wireshark, maybe I was doing something wrong, let me know in the comments, because now that's something that's going to bother me before I go to bed. Because I know it's in there. I'm going to do the PCAP again, but if you have any questions, please let me know. I'll be happy to answer any questions that you might have. So here's my second PCAP. And again, here's my netcat file. The machine is in the description for this video. So if you look in the description, there's a link where you can download the machine. This was just a get for netcat, which I should be able to see that file. I guess not in this case. I've done it before where I'm actually able to export objects from here. I guess. Yeah, that's the packet I should have chosen. Anyway, does anyone else have any other questions that we can answer here before we call it a day? We'll be doing even more machines here in the coming weeks. We've been doing this for over a year now. Every weekend we were here grinding. This is how it's done, right? Every weekend we show up, we do things. We show up, we do things. And we get better. So if you really like this stuff, make sure to make an appointment with me every Sunday. You and I will be learning these things together. As you can see, I never claimed to be an expert, but I know for a fact if I keep doing these things, if I keep practicing, there's only one thing that happens. I get better. Yes. So Security Onion is running in Security Onion is just installed on bare metal right now. It's actually running on a Dell 610. It's a Dell 610 server where it's running. So if you look in, I can show you the resources for it here. So the way it's set up is Security Onion is running on a server. The server is getting mirrored traffic from a 1 gigabit switch. It's a Cisco Meraki switch. I have two ports, one port that's connected to the machine that I'm attacking, one port that is connected to Security Onion. Then I'm just mirroring the traffic. A copy that goes to the machine that I'm attacking is also going to my intrusion detection system. That way I can see everything that is happening. And I like real hardware because it performs better. So I don't know if you can see here, but this machine, I believe it has 32 gigs of RAM and a decent CPU. I've ran this in a virtual machine. It will still work. It will just be a little slower. But this is what it looks like in the monitoring in Security Onion's monitoring. As you can see, because I have overcommitted a lot of resources, I'm not using a lot. It's probably too much. Yeah. So if you like, please join our Facebook group. It's called IT Security Labs. That's where I think a lot of communication can happen better. Otherwise, you can also subscribe to the channel and be part of the community. I also look in the community as well. All right. This is how it's running, and as you can see, I'm not even losing any packets on Suricata, which is amazing. I mean, this is gold right here. The fact that I'm not losing any packets when I'm doing this, because as you do detection, this is what you care about. Am I losing anything? Is something happening that I shouldn't? As you can see, my CPU usage is very low as well, mostly because this is hardware and I'm only looking at one machine. I'm not looking at, thousands of devices or anything like that. And my PCAP retention is kind of good too. I can keep 23 weeks worth of PCAP at the rate that I'm collecting PCAP right now, which is nice. Good questions, good questions. So if you haven't, I've made about 7 or 8 machines. Look on my channel, attack all of them. There are some machines that are very, very good. A lot of people have been passing the OSCP. Some people told me that my machines were very close to what they saw. So I highly encourage you, if you're going to go for the OSCP again, attack my other machines, especially given that they're all Windows. When I went to the exam, I had 3 Windows machines and 2 Linux. That's how big Windows is. So if you attack all of my machines, I am sure that you'll come back and you'll come and tell me that you did learn something that helped me, that helped you in the exam, especially the multiple ways on getting reverse shells. Not just one, you need at least 3 or 4 ways. So check out my other machines. If you haven't, please subscribe, and also make sure to like this video, and come back next week at the same exact time, 9 p.m. Central Standard Time. We'll be here, and I'll actually be attacking yet another machine. So thank you very much for being here, and I'll see you next week.